Motion in a plane. So before we actually start motion in a plane, let's define what motion in a plane is. Well, motion in a plane is basically anything that travels that is non-rectilinear. What is non-rectilinear? Just means that it doesn't necessarily have to travel in a straight line. In the previous chapters, which is rectilinear motion, it deals with everything that moves in a straight line. So everything was pretty simple. You didn't have a lot of angles to worry about. You didn't have to worry about vectors or any of that sort because it was pretty simple. So what we're going to do now is, before we actually start motion in a plane, let's wrap our heads around the idea of scalars and vectors. So it's fairly simple. It's just that now, since we started actual classical mechanics, let's actually differentiate scalars and vectors properly once and for all, so that we don't have doubts about what exactly are vectors, what do we classify as vectors, and things like that. So what is a scalar, what is a vector? Well, both of these are quantities, or a measurement of a quantity. So we have two, right? We have a scalar and we have a vector. Now, I'm pretty sure everybody knows the difference between a scalar and a vector, but we're just doing this just so that we're 100% sure. A scalar is a quantity that does not have direction. So I'm gonna just say no direction. Now, a vector is something that has direction. So let's say direction. Yes, direction. Alright, so a scalar doesn't have direction, a vector has direction. So they're best explained with a bunch of examples. So let's just get a bunch of examples and see how exactly we can define them. Let's think of mass. Let's think of mass. Now, what is mass? Now, mass isn't how heavy something is, because if I weighed X kilograms here, if I went to the moon, I would be 1/6 of how heavy I am. So we can't really say that mass is how heavy something is. Mass is actually the space occupied by a bunch of particles. So let's take an example. Let's think of a block of something. What do you want? A block of gold, for example. A block of gold. Let's say it's 500 grams. Now, I'm not saying in physics that this gold weighs 500 grams. I'm saying that it has a mass of 500 grams. That means on Earth it would be 500 grams, in a vacuum it would be 500 grams, on the moon it would be 500 grams. That does not change, because the mass of all the particles of gold in here are adding up to 500 grams. So, does this mass act in any direction? Well, no, it doesn't. You might, some people get confused and might think, okay, no, but it acts downwards, right? But no, that's not mass. That is actually weight, which has a direction, which is in the direction of gravity, right? So mass would be a scalar because there is no direction, whereas weight would be a vector. Now, the unit for weight is not gram or kilogram or whatever. It's actually Newton. Why? Because weight is simply a force. You know, the equation of weight is mass times the acceleration due to gravity, and this looks familiar because force is just mass times acceleration, and we know that those are two accelerations, and the unit for force is Newton, or kilogram meter per second square, which means that the unit for weight would also be Newton. So weight is a vector which always acts downward. So if I took my same block of gold, that's 500 grams, right? And it's sitting on something, gravity is acting downwards, so we have weight acting downwards. And this would be 500 times 9.8. We could just round that off as 10, so we have 5,000 grams, which is 5 kilograms, right? Yep, 5 kilograms. So that's a heavy block of gold. Anyways, So now we see a basic differentiation between what a scalar is and what a vector is. I sounded German there. What? All right. So let's take another example. What about speed and velocity? A very classic example of the difference. So we have let's say a car. That's a car. All right. It's going, say, 50 meters per second. All right. And say it's going in that direction. All right. Its velocity is what? Now people say, yeah, its velocity is 50 meters per second. Say the same car, why am I drawing it like that? We have the same car going in this direction at 50 meters per second. What would its velocity be? Now, since we knew that this one is going in this direction and it's 50, obviously this one going in the opposite would also be 50, but with a minus sign. So you might think, what? Well, yeah, that's how we differentiate a vector. See, these two vectors are not equal. One of them is 50, the other is minus 50. The speed is same for both of this, but the vectors are actually opposite. So the way we represent a vector is we put a little arrow on top of the alphabet. So V would be 50 meters per second, and this, let's put 2 there, and this would be minus 50 meters per second. Acceleration is also a vector. So acceleration, we said force, we said velocity. So see, we put a little arrow on top to differentiate a vector and a scalar. So speed is a scalar. So speed, the reason why I didn't draw anything is because we can't draw anything for speed. Speed is just the magnitude. So the magnitude of velocity, is speed. But when we add a direction to it, saying that this car is going, say if we took this as east, this car is going east, that's a velocity. This car is going west, that's a velocity. So since we've understood the basic differences of a scalar and vector, this is all. This is the main difference. But as we go ahead, we're going to see how we're not going to worry about scalars at all anymore. We're only going to concentrate on vectors. We're going to see how these vectors don't actually follow general arithmetic. It actually follows its own type of geometry, which is vector geometry. The laws of addition, the laws of multiplication, division are different than that of normal scalar multiplication. So we're going to do that in the next video. This was just to demonstrate the main difference between a scalar and a vector.